Um, we do a lot of the same things that Fabian does. So I'm going to try and give some different perspectives. This is other things to think about. And so I'm going to give you some intuition into what I've seen that works, what doesn't work, and things that I've seen that fail miserably. Um, and so I wanted to continue to set the legal stage just so that we're all on the same page. I think we've become quite clear with the fact that the legal basis depends, at least if you look at this around the world and within your country, that the legal basis changes from province to province and from country to country. And so what works in one place doesn't necessarily work in another. So just picking something up from what works in the US and moving it over into Switzerland is not necessarily the right way to go. But I'm going to give you some intuition into what we've been doing in the US more generally so that you can see how things have played out and why things don't always work. And the problem that we run into is that we have laws at the federal level. What wasn't mentioned is what's called the common rule. The common rule corresponds to all data that's collected on human subjects for research purposes. I'll talk a little bit about this in a moment. But we also have HIPAA, which is what happens when you have data that's collected in the healthcare setting. And these two regs are actually in conflict with one another at times. We also have rules or laws at the state level. One of the more interesting ones at the moment is the California Consumer Protection Act, which actually looks a lot like GDPR and is different than HIPAA and the common rule. So the common rule, the reason why I bring this up is that what's interesting is that this is a regulation that applies to only government-sponsored research. And so if it's not government-sponsored, then people don't have to adhere to this, which is why when you see companies like Google and Amazon doing studies with data that they've collected, they're not subject to this type of oversight. And so they create confusion because they'll say they're doing de-identified research, but they're actually not actually doing it in compliance with any specific regulation. But what's interesting about this is our definition of human subjects. So in the US, a human subject is defined as only a living individual. And this is somebody that the investigator who is conducting the research has collected data on them through some intervention or interaction with them, or it's identifiable private information. And so if this was information that was in the public domain on somebody who was dead, it's not considered to be human subjects. So in the US, in other words, when research is being done with individuals' records, your privacy rights just die with you. And this has become an interesting principle because it means that you can hold data to two different levels of standards. People who are alive, their data needs to be protected under the reg. People who have died, they don't really need to have any protection afforded to them because according to this, they have no privacy rights. So there's been lots of questions about genomic data. In the US, this is not considered human subjects. It's not considered a human subject. However, our government has said that they will revisit this over time. And the first reconsideration that's on the table is whole genome sequencing. But this was something that they said would happen back in 2017, right as Obama was leaving office and the common rule was revised, but it has not been revisited at this time. And policymaking in the US moves at a snail's pace, and I would not expect this to happen anytime soon. The link that I have here actually is associated with how GDPR perceives this. And though GDPR gives some special designation with respect to genomic data and how it's designated as personal sensitive information, there is a research group over at Cambridge that's sponsored by PHG that has been looking into this issue. They published this 200-page report talking about all the different circumstances under which genomic data should be designated as personal data and when it shouldn't be. This is one of the most fascinating reads I've had in the last couple of years. Well, that's really sad if you really think that this is one of my most fascinating reads, but it really is amazing to read. I strongly recommend it. Okay, so this is the common rule. This sets one type of basis for what you need to do for data protection in the U.S. I then wanted to talk a little bit about HIPAA because it was mentioned earlier. And so as we've seen, GDPR has a definition of what is considered to be anonymous. And I'm not going to go through that definition, but this is highly similar to what HIPAA says is de-identified, only there's some interesting terms that we use, and that it says that it's information that does not identify an individual, and there's no reasonable basis to indicate that the information could be used to identify someone. And so in the US, we have this notion of what's called safe harbor, because there's two different ways to do de-identification under HIPAA. One is what's called safe harbor, and this is where you remove 18 types of identifiers that have been explicitly enumerated and documented in the regulation. And then you further have to attest to the fact that you have no actual knowledge that the residual information can identify somebody. This is a really interesting precedent, because what it says is that if you do everything that the regs tell you need to be done, but you still have an indication that somebody can be identified, not that you have a suspicion they can be, but that they can be, that if you do not address this within the data, then it was never de-identified to begin with. I think what's really fascinating about how our guidelines or how our regulations have evolved over time is that this was not what Congress initially put on the table. They initially started with what was called an expert determination perspective, which said that you would apply generally accepted statistical or scientific principles to show that it would be a very small risk that an anticipated recipient could identify somebody. I love this perspective because this means that you have to perform adversarial modeling. You need to take into account the capabilities of who you're giving it to, giving the data to, and it's interesting because this is non-trivial. This implies that there is a systematic approach that needs to be applied, and it is context specific. When this was first suggested by Health and Human Services in the US, because they're the one that oversees HIPAA, they basically told all of the healthcare organizations in the US that this is what we want you to do. And they said, well, how do we do it? And Health and Human Services said, well, we don't know how to do it. We expect you to figure out how to do it, or you tell us how to do it. And they said, well, we don't know how to do it. And so that is where Safe Harbor came from. And Safe Harbor became this cookbook that was how organizations said, well, we can do de-identification without having to think about it. Now, there is a big difference between I think we've talked about this a little bit, but I wanted to just make sure that we're all clear. There's a big difference between de-identified and anonymous data. And the big difference is really in this notion of pseudonymization. And I think that's something that you're going to have to wrestle with. I think we've already beaten that horse a bit, so I'm not going to talk about it a little more. What I did want to point out is that this notion of de-identification in the US is actually only a small piece of a much bigger picture of how data gets used in a secondary manner. And it's not the only way that organizations pursue data sharing. So we actually reuse fully identified medical records. We can do this with waivers of consent if the data is on the shelf, and we can show that consent is impractical to obtain. So for instance, when I'm doing de-identification research and I need access to millions of medical records, I can go to the Vanderbilt University Institutional Review Board and ask for such a waiver so that I can work with that data. But that is subject to a benefit risk calculus, and they may say at times that I'm not permitted to actually do that. And so there's an alternative that was set up within HIPAA, which is what's called the limited data set, which says that you remove 16 specific identifiers or types of identifiers, and then you enter into a use contract that says you will not misuse the information and you will not attempt to re-identify the people. And those are slightly different things, because misuse is a difference. You're doing something different than what you said you were going to do with the data. You'll study, for instance, like ancestral heritage of a population when you only said you were going to study if they had diabetes. What's interesting is that if there's a violation that takes place with either of these situations, that the federal regulation, the federal government is allowed to apply penalties. And this is important because this is how you incentivize or disincentivize the system. This is why de-identified data is actually quite strange, because de-identified data says that, at least in the US, the regulation no longer applies once it's de-identified. And when somebody, if somebody was to commit a re-identification using de-identified data, the federal government has no authority. The only way that they would have authority would be to show that the initial sharer of the data was negligent in their ability to de-identify the data, but that the recipient of the data may not have done anything wrong at that point. So this is a big loophole in the way that our laws have been constructed. This notion of safe harbor and why safe harbor is so dangerous, I think I'll illustrate as an example in that it's what you call an exclusionary policy. It says, it gives you the list of fields that you should not include in a data set. But I can tell people race, I could tell people their ethnicity, I can tell sex and sexual orientation. I could talk about an individual's number of marriages, their job, their education, their socioeconomic status, how many children they have, what language they speak, what religion they have. I can keep going on and on. None of this is actually precluded by the list of things that Safe Harbor says is not permissible. But you can see that this starts to create a dossier on an individual, and it makes them unique really quickly. And this is one piece of the puzzle, because in reality, that's one person. And I can start telling you about who they're married to, and then I can start telling you about all of their family structure. And again, none of this is prohibited under Safe Harbor. And this is the type of information that many organizations in the US are collecting and sharing and are claiming is de-identified. And yet it really doesn't take many pieces of information to uniquely represent someone, but they get to stick their head in the sand and say that this is de-identified according to the regulation. This is really dangerous. All right, so this can keep going on and on. So what we've tried to do is encourage people not to go the Safe Harbor route, or at least not to use it on a large scale, because the way that big data has evolved over the last decade, it just creates a big problem. So this is the specific language associated with the expert determination approach under HIPAA. I don't need to go through this. I just wanted to highlight the fact that it is all about risk management. And why people really care about this goes back to, and some of you may already know the story, is because of the fact that we know that a combination of features, the demographics that are included in typical hospital data, can uniquely identify somebody. And at least in the US, it's easy to get registry information that you can use to try and re-identify individuals. And this is really critical, because when you're doing policy making and when you're trying to convince people why they need to do something, it's hard to do it without showing that it can actually happen. And so this was what happened in the 1990s before we had HIPAA. The guy you're looking at on the right, this is William Weld, who was the governor of the state of Massachusetts. And it was shown that his data was in hospital discharge data that was being shared for comparative effectiveness research and biomedical research in general. I won't go through the whole story of how this happened, but this is this one incident, a major incident that ended up leading to where HIPAA actually came from, because this all happened before HIPAA, right? And all that was shown was that his date of birth, his gender, and his zip code was sufficient to uniquely represent him, but then it went one step further and said, so just because he's unique, that's one thing, but we can actually find him in other resources. So these studies, this notion of 5-digit zip code, birth date, and gender, this is where our safe harbor comes from in the US, because it was shown that the majority of the US population was unique on these factors. And so the safe harbor notion kind of grew out of the limited data set. So what I alluded to earlier, where there were 16 enumerated features, this is the summary of those 16. And this is the exact definition of what our safe harbor corresponds to. Now, the reason why context matters here is that we do things in the US, like saying that you can disclose the data provided that you have the first 3 digits of the zip code maintained. So you truncate from a 5-digit zip code into a 3-digit zip code. This doesn't translate into other countries. There is no simple way in order to make this type of a distinction. And so there is a threshold that was associated with our geocodes that said you needed to have a minimum of 20,000 people within that region, but most geocodes with zip3, they have way more than that. So just using 20,000 as the threshold is completely arbitrary. So a lot of places around the country look at the US and they point towards safe harbor and they say, this is what we want to do, but there's no direct translation. So CCPA is an interesting perspective because it acknowledges that there are residual risks in things like safe harbor. And so their definition in California of de-identification says that you've got to go and change the data, you've got to control the data, but you then have to do additional things. You have to have technical safeguards in place and prohibitions on re-identification. You have to implement technology that prevents the inadvertent release of the data. And then you have to ensure that whoever's receiving the data attests to the fact that they will not attempt to re-identify. And if you don't have documentation on those latter 3, you don't meet the criteria for de-identified in the state of California. And so even though you might meet HIPAA, you may still be in violation of the state law. So this is something that a lot of hospitals and organizations in general are trying to deal with. I can tell you a lot of companies that work in healthcare technology, like big data type of situations, they're wrestling with this on a daily basis because they have some people who come from outside of California, they have some people who come from inside California, and they're trying to figure out if they manage them separately. So you can go off and you can issue guidance. It can be done at a lot of different levels. So what I'm showing you here are guidance that are issued by federal authorities. So in the US, Health and Human Services recognized that there was a lot of confusion around what an expert determination actually looked like. And so they issued their guidance back in 2013. I'll be honest, I was the one who wrote that guidance. The problem with it was that it went through review at 18 different federal agencies and was completely cut down from all the recommendations that we had made because we were told that we did not have the authority to do policy making. We could only provide clarifications. It was extremely frustrating. Because at the end of the day, we didn't actually tell people what methods they should be using. It just said, here is an example of a type of method that you could use. The European Medicines Agency, Fabian gave an allusion to this, he referenced it. They're actually much more prescriptive. They give an actual risk threshold. They don't tell you how specifically to compute risk, but they say that risk can be no greater than 0.09 in a data set. But so that's an example of what happens at a governmental level. You can also see guidelines issued by various societies and consortia. So FUSE, for instance, has provided de-identification standards for clinical trials data. HITRUST has put out their own de-identification framework. These are not legally binding and they're not required by use for organizations that work with them, but they're just general, here's how you can get up and running type of guidance. A couple of things I wanted to point out is that there's also a difference between law and policy. And so our National Institutes of Health has multiple policies on data sharing. And the data sharing phenomenon really started back in 2003 for us when the NIH said, look, if we give you at least $500,000 in a year for a research study, you need to figure out how you're going to make this data available. As genomic technologies became more prevalent in, a couple years later when GWAS became popular, they said, we don't care how much money we give you. If there's genomic data involved in the study, you're going to figure out how to make that data available. And then in 2014, they said, okay, well, we've moved way beyond GWAS and any type of genomic data, you got to figure out how to share it. And so that's the 2014 genomic data sharing policy. Then the problem was that the NIH did not come up with their own guidance. this is where they said, look, we are going to punt and we're going to go look at HIPAA, which is really weird in the US because these are research studies and normally the common rule would apply. But instead they said, go look at a law that is associated with clinical data and the clinical domain. And the reason why this is weird is that they got things completely wrong in their policy. They basically said that if you're going to share data, you need to strip the 18 identifiers listed in the HIPAA privacy rule, which means you need to go do safe harbor. You're actually not allowed to use expert determination when sharing any data associated with genomic data in accordance with the genome data sharing policy from NIH. This is bonkers, and it has led to a very large amount of data truncation that is occurring in the US. All right, so I've shown you what happens on a very large scale, and then I'll show you what happens in a couple of very specific instances. So Vanderbilt built its own de-identified environment for its medical record system. I think we were one of the first places in the world that did this with biospecimens as well. So we took all structured and unstructured data, and we took what was called, so this is our research derivative. In other words, we took data out of the clinical domain. We created our own research warehouse. We then created what's referred to as the synthetic derivative. It's a horrible name now that we have synthetic data, but this is not synthetic data. It's just what we call the synthetic derivative. It's a de-identified environment where we have sanitized all the natural language text, and we have controlled all of the biological data as well as the imaging data. And we've one-way hashed everybody based on their medical record number locally. We then, so you know, with natural language, and because this came up earlier, I threw these slides in here a couple minutes ago. There's a big challenge here in that, you know, we have developed technology for doing sanitization, but it's never going to be 100% perfect. There's always going to be things that leak through. And we've done this by so the way we've done it is we have rule systems that we've combined with machine learning. Conditional random field-based technologies have actually worked really well. They're comparable and many times better than deep learning technologies because they can learn on a smaller amount of data. A lot of the technology that we use is available in open source technology that we developed almost a decade ago called MIST that I developed with the MITRE Corporation, but there's also software that Hua Shu's group at the University of Texas has developed called CLAMP, which is deep learning based, that works as well. But this technology, I like it because it gives people the ability to annotate what they're doing, to train machine learning models. But the other reason why I think it's interesting is that what we've implemented is we've taken it a step beyond just redaction, and we do what's called resynthesis. So this is similar to synthetic data in that whenever we do redaction, we substitute the term with another term so that you can't recognize, or be difficult to recognize, what was a leaked piece of information and what was synthetic information. We've evaluated this with humans to see how well they can recognize the differences between the two. And if you do it right, it's really difficult for humans to recognize the difference. I'm not going to go through the details here. What I did want to say, though, is that natural language sanitization is a dangerous game to play, because just because you can enumerate all of the potential identifiers doesn't mean that you can get the semantics correct. And so, for instance, we've had instances where it says, like, you know, the football quarterback of the professional football team. That is not going to necessarily be captured by standard list of identifiers. Or as I'm showing here, you know, it's something that says the senator's wife. And this is why use agreements in controlled environments is critical, because we acknowledge that there's residual risk. So we've also, everything I just described to you was we took the EMR system and then we took biospecimens and we extract DNA lysate and then we make sequences available for research purposes because it's considered permissible under well, HIPAA doesn't say what we can. The one thing I wanted to clarify though is that we are extremely, at least at Vanderbilt, we were extremely careful about how we did this in relation to our community. And we did not do this without actually we created a community advisory board that we still have in place until this day, that every quarter we give them an update on what we're doing with this repository so that they have a say in how it gets structured and how it gets used. Even though it's an opt-in environment, so we're not reusing all the data. Though we have the legal right to do so, we've still given people the ability to step out of this type of a research environment if they want to. I just wanted to make that clear. Okay, two more points. One is that we have created multiple tiers of access to the data. So we have set it up, and I know that some of you are familiar with systems like I2B2, in that we basically set up that type of a research infrastructure to allow for initial hypothesis generation, but we do aggregated results. We return aggregated information at the first tier. So somebody could issue a query that say, I'm interested in people with juvenile diabetes, they're on an antipsychotic, and they had an adverse event within 3 months of starting the antipsychotic. We give them aggregate results back without showing them the individual level records. If they then want to move forward and they want to get access to individual level records, then they come forward, they sign the use agreement, they come forward with an IRB approved protocol, and we'll give them records back for them to process. This principle is kind of what we're doing on a large scale now outside of Vanderbilt. And so Vanderbilt is kind of like a proving ground. We're now doing this on a multi-institutional national setting through the All of Us program. If you're not familiar with All of Us, this is our program. NIH has kicked in about $2 billion to get a 1 million person or more cohort of all electronic medical records, genomic data, and patient contributed information. We're also collecting mobile data as well. And we're doing 3 tiers in All of Us. One is the public tier. All data is rounded to increments of 20 in terms of the query responses that we provide to people so that they can't triangulate with respect to multiple queries. And then we've also created multiple levels to individual level data. One is what's called the registered tier, where we're working on giving access to just about anybody who requests it, but we heavily amend the data. And then another one, so we released the registered tier about 4 months ago. And then we're going to be releasing the controlled tier at the beginning of next year, which is going to be much more specific information from more trusted investigators. So this notion of risk, so what I just showed you is behind the scenes, what's working is we're looking at 2 different factors playing against one another. On one side, we're controlling the data, and we're saying that the chance that somebody could be re-identified is dependent upon how unique they are, how replicable that data is in other settings, and how much people can get access to it. But it's controlled by how you grant access to it. So there's a big difference between letting anybody in the world have access to it and letting your trusted set of researchers within the hospital settings have access to it. And you have like your ability to calibrate the amount of detail that you're providing in the data as an artifact. So it's not just the privacy utility trade-off. Sometimes utility is comparable to the number of people that you're allowing to have access to the data as opposed to just what the level of detail is in the data. I'm not going to go through the details of the registered tier, but I am going to make the slides available afterwards. But we did a lot of hand-curated rules. And so then the last point I just wanted to say is that, and I hope that I've made this point clear, is that this notion of anonymization or de-identification or whatever word you want to use, it is not your only solution. It should not be the complete solution because there's always going to be a risk. And you just have to acknowledge that this risk is real. I think the big challenges here are you have to figure out what is an appropriate level of risk. As I mentioned, EMA said 0.09. Where did 0.09 come from? What does it mean? Really what they did was they took a look at what the Centers for Medicare and Medicaid Services in the US were doing, where they said you can't share any cell counts that were of size 11 or smaller. And they just said, oh, okay, so then risk would be 1 over 11. You can't have a risk for a record that's greater than 0.09. Who got to decide 11? I don't know. Different groups use 5, different other groups use 20. You have to ensure accountability. If you, I worry about data that gets out into the public domain for which we have no control. I strongly recommend that you harmonize your data sharing principles. And it sounds like this is what you're doing, but I still wanted to reinforce that fact. And that you need to involve the community, or at least you should, to the extent that you can, because if there's de-identification that is performed, the data is shared, there is a breach at some point in time, you really wanted people to know that this was something that you did. Otherwise, you will kill trust with respect to the patient populations whose data you are studying, and it will be extremely difficult to get it back into the future. I think that the University of Chicago and Google, if you're not familiar with the case that happened last year, I strongly recommend taking a look at it, because the University of Chicago is getting crushed right now by their patient population in terms of what research they can and can't do. I strongly believe in the use of data use agreements and this notion of making risk proportional to who you're giving the data to. Okay, so I don't know if I went, I'm sure I went over time. I just kept going. But if you have questions, that's what the rest of the session is for, and who's not on email.